So I want to do kind of a bells and whistles piece as well for some of the other stuff that's going on in the chapter. That especially for those who feel more confident already with R and R Studio, that you might be interested in how to get a little bit closer to what's going on in the book itself. So the three pieces that I want to talk about here are equations, which come up in chapter 1.1. So I'll add this in. So how to format equations using R Markdown. And actually before that, there's also this piece in 1.1 of creating new variables. Variables, and particularly these are categorical variables. And then the last pieces in chapter 1.1 are things like the idea of centering the mean, and that will be related as well. So the first piece of creating this new variable, if we were to go back, at least in the second edition on page 23, we'll see that they started this off not with the scatter plot directly, but actually this bar chart with the three different categories of mileage. So sort of a lower mileage, medium mileage, and higher mileage. But that variable is not actually created or it doesn't come in the data set directly. So we have to create that. And so we're also going to use the tidyverse for that here. And as I said in a previous video, that we can suppress that output that happens with tidyverse that's telling you what different versions that are getting included and whatnot, with a couple of options in the R code chunk starting point. I don't even know what this is called, but that within that kind of curly bracket, you can include message equals false, so to suppress any messages, warnings. You can also do this with errors, which I actually don't recommend, at least initially, because then it won't necessarily tell you that something's gone wrong. And the last piece is echo equals false, which suppresses the code. So we'll load in the tidyverse, and then what we need to do here is to create a new data or a new variable in accord price. So let's start with accord price, and then this first line is really saying in English, save into accord price everything else that follows. So everything that follows this, the sort of arrow here, is going to go back into the data set called accord price. And what we're going to do is to start from accord price and use this pipe to string together multiple lines of code. So this is sort of like saying and then. We're going to use the mutate function that creates new variables, and we can call this mileage group. It doesn't really matter what we call this. And we can create this variable with a few different logical if-then statements, or rather, it's an if-else statement. So if we say if-else mileage is less than 25,000, then let's call this low. And then if the mileage is not less than 25,000, so if it's anything above 25,000, then you have to tell R what to do. So the other category here that the easiest way to do this would then be to characterize the top value, right? So the high is anything that's above 65,000. And then we have this sort of third piece is what happens if neither of these is true, right? So if the mileage is not less than 25, nor is it over 65, then what? And so then we're going to call that anything that's left there is in the middle. You might want to get a slightly more nuanced or sophisticated code here if there were missing data, but we know that there aren't, and so this actually does just fine for our purposes here. I'm going to also add let's actually just see this. And then we can create the box plot from these data. So we'll, instead of having mileage, we'll have mileage group on the x-axis. And here we need to then specify what kind of plot we want. So this could potentially give us, it will default to giving us a point plot, which is what we want out of a scatter plot. But what we're looking for to replicate what's going on page 23 is this box plot instead. So I'll actually just knit this whole file, and that will probably be a little more straightforward here. And so then, right, this shows us all of the code of how we created the different variables, what they are. And then this is the plot. So it is somewhat similar to what we see in the book. The main difference is that they're actually ordered by alphabetical order. So H comes before L, comes before M. So high, low, and middle is how they're ordered. And we would need to go back and tell R how to order these values. The easiest way to do that is by calling this, or when we're creating this variable, as a factor variable. And this is sort of a wrapper around that. There are a bunch of different types of variables, right? Numeric, categorical variables get called either factor, or they're just treated as characters. So if you had something like an address, that's should be treated as a character variable, but not necessarily as a factor, which is really like a category. Like class year, if you had first year, sophomore, junior, senior, that would make sense probably as a factor, because those are really ordered categories rather than just a bunch of character text. So what this does, it allows us to then define what are the values that we want, or the order of these groups, because now we have told R that these should be considered as a group. And so we can use this, we can clarify what this factor is. So here we're using base R code, where we're saying in this data set accord price, find the variable mileage group. We tend not to, in a lot of our SDS courses, use this kind of approach, where things are linked between the data set and the data frame and the variable name with a $sign, but instead to try to string lines of code together with this sort of approach instead. Factors are this one place that still don't lend themselves to quite as nicely to this sort of framework. So in fact, we kind of have to create the variable in one step and then tell R how that should be ordered in another. So then what we're saying here is that the factor variable mileage group, its levels should be C. So this is where we're including a list, and so we want this to be high, then middle, then low. And then when we run this, it should create the order that we want in this chart. Oh, and I have reverse ordered them, but at least that they are in order now, in a way that's similar. What you also notice is that the plot in the book is actually the spacing is a little bit different than what's going on here. This keeps them evenly spaced. That actually sort of creates what looks like maybe a stronger relationship than is actually there. So just be careful about kind of what's going on. But this does create for us this idea of being able to look at different kinds of data visualizations, not just scatter plots. So then I will just fix this just for the sake of it. So then if we do low, middle, and high instead, that will be the order that we want in the subsequent times that we do this knitting. Then below that on line 23, or I'm sorry, on page 23, they have a bunch of equations, and this becomes, we end up writing a lot of equations in this class as a function of regression modeling, and so some people will want to use this kind of approach of nicely formatted regression or any kind of equation. So Markdown lets us use ways to do that by putting what we want to be considered as an equation inside dollar signs. So in between two dollar signs, let's just write the first of data equals model plus error, and you'll see that just popped up and generated what the fitted or the formatted rather equation is going to look like. And you'll see that actually it looks quite like what it is in the book. These $2 signs are a way to say this should be centered, similar to how it is in the book, right? If you look at the sort of paragraph, that all of those equations are right in the center of the text, not on the left-hand side. You don't actually have to do that for any particular reason other than it visually sort of creates a little bit more differentiation between text and the equation. So that works fine and pretty straightforward when you have text of like English data equals model plus error. But when we're wanting to create something that has more a more complicated model with different characters, let's look at the bottom model where we have just before example 1.2. So we have y, or our response variable, equals beta naught plus beta 1 x plus epsilon. So here's where this starts getting a little more complicated, where instead of inserting the beta character, you can use a / beta. And let's just have the dollar signs end that equation just to illustrate that that's where this / beta gives us the formatted Greek symbol for beta. If we want to express beta 0, we can then include a sort of subscript, the underscore and 0, and that will include that as well. So then we can add plus, and we know how to do this now. So there's beta 1, and it's beta 1x. So you don't need to have a space in between here, but if you do, it will just continue to format that for you. It's probably easier to read it if you have the space there, plus epsilon, which I can never remember how to spell right off the top of my head, and I did it right the first time. So that gives us this fitted equation, or really this hypothetical equation. Once we fit it, then these betas get hats, and that adds more complexity to this equation. And in fact, so looking ahead to then page 24, where these do get hats, so we can start with what we had before. Once we fitted the equation, the epsilon goes away because the epsilon reflects the amount of error that's in the regression model. And since when we fit the regression model, we can actually quantify the amount of error, right? We know that that's a reflection of the residual. And so it's really kind of baked in, if you will. So instead, then we can use sort of similar, we can put this there we go. So we can precede beta 0 with this / hat, and that will put this little hat over the beta. And so we can do this again for beta 1, and this will be beta 1 x. So this is what the kind of middle equation on page 24 of the second edition is looking like. This gets really complicated really quickly, and at least in terms of how error prone this can be. So you can be futzing with this to like, sometimes it will want a space in between the end of the equation and the dollar sign. Sometimes it doesn't like that there's a space. I suspect that when we go to knit this, this may throw an error, even though this seems to be generating just fine here. So I would encourage you to proceed pretty cautiously here. It's completely fine for the purposes of our class to say things like, instead of writing out this kind of equation, to say like y equals beta 0 plus beta 1 plus e. That's completely fine, and you don't need to do this sort of equation business. And I, in fact, am trying to sort of encourage you to really think about this as an exercise in practice, and that you'll get it, but it can be really frustrating. So just know that you can simplify and do the most straightforward approach of just typing it out in text. So let's just knit this again, see that whether that's going to run or not, and will give us those equations. Right, so then here we have this, now it's in the order that we would expect it to be. And here in the center, we have data equals model, right? We have our three different models that we would, or equations that we were expecting. And then the last piece that they talk about in this model that is kind of similar, or in this chapter rather, that's kind of similar to having created this variable before, we'll have to create a new variable again in order to center the mean. And this, we're not going to do this sort of approach much in this class, but it's a useful exercise in thinking about how to create this kind of variable. So what we need to do here is to calculate the mean of the mileage so that we can subtract that from each individual value. So the first thing that we'll do here is, I'm going to take this all out. We're going to want a different kind of coding structure, but we're going to use the same mutate function. So we're going to want to say, I'm going to do this in two steps. I'm going to say the mean mileage, and actually, I'm going to do this by saying summarize, and then the mean mileage equals the mean of mileage. So what this is doing, this is again a different function from the dplyr package that's going to do things like calculating the mean, the standard deviation, the median, the quartiles, the percentiles, etc. So summarize and mutate know each other. And so this will actually create this variable called mean mileage that is the sum of or rather the mean of the values for mileage. And then we can string these lines together and say mutate, and they call this mileage C equals mileage minus mean mileage. And that should create this variable that we're wanting. And again, it's getting a little tricky to run this iteratively, so I will assume that that's going to work, and we can test this by running the model as our way to double check. So then we can say 1.1, let's say centered, and we'll say mileage C. And now let's just knit this file and see if that works. Right, so there's something happening here that I am not positive I know what's going on. This is a good exercise in how to break down and troubleshoot some code. So let's, okay.